Welcome to today's session on TRIZ, the theory of inventive problem solving. Over the next few minutes, we'll explore how TRIZ helps innovators crack tough challenges and create breakthrough solutions. Now here's the magic of TRIZ. It tells us, don't settle for trade-offs. Solve the contradiction itself. Take the smartphone battery problem. Instead of just making batteries bigger, TRIZ would suggest using principles like segmentation or energy substitution. That's why today's phones use multiple smaller cells, fast charging, or even wireless charging, all TRIZ-style solutions. For cars, the contradiction is speed versus safety. TRIZ points us to principles like cushioning, dynamics, or feedback. That's how we got airbags, crumple zones, and advanced driver assist systems. So what looks impossible at first becomes solvable when you apply TRIZ principles systematically. Here's another real-world TRIZ example, transforming a window AC into a split AC. A window AC is compact and simple, but it's noisy, blocks windows, and limits placement. On the other hand, a split AC is quieter, more flexible, and efficient, but it's more complex to install. TRIZ solves this by applying separation in space, splitting the unit into indoor and outdoor parts, and dynamics, making the refrigerant flow and cooling adaptable. The result? All the benefits of a split AC without the drawbacks of a bulky window unit. TRIZ might sound complicated, but at its core, it's the theory of inventive problem solving. It was developed in 1946 by a Soviet engineer named Genrikh Altshuler. While working in a patent office, Altshuler reviewed over 200,000 patents. He noticed something remarkable. Innovations weren't random. They followed patterns, repeatable principles that inventors across industries were unconsciously using. Altshuler turned these patterns into a structured method, TRIZ, that anyone can apply, whether you're an engineer, designer, or problem solver in business. Today, TRIZ is considered one of the most powerful tools for systematic innovation. Most of us are taught to solve problems through brainstorming, throwing random ideas on a whiteboard and hoping something sticks. Sometimes it works, but most of the time, it feels like searching for a needle in a haystack. TRIZ changes the game. It tells us that innovation is not about luck, but about patterns. By studying past inventions, TRIZ gives us a structured, step-by-step method to turn contradictions into breakthroughs. That's why TRIZ matters. It transforms creativity from a chaotic guessing game into a reliable system of innovation. Whether you're designing products, improving processes, or solving everyday challenges, TRIZ gives you a clear roadmap. At the very heart of TRIZ lies the concept of contradictions. A contradiction happens when improving one feature makes another worse. Think about it. We want a car to go faster, but faster usually means less safe. We want smartphones to be thinner, but that reduces battery life. We want machines to be more powerful, but that often increases energy use. TRIZ teaches us that real breakthroughs happen when we resolve these contradictions without compromise. Instead of choosing between speed or safety, power or efficiency, thinness or battery, TRIZ helps us invent solutions where both sides win. This is why Altshuler called contradictions the engine of innovation. By facing them directly rather than avoiding them, inventors unlock creative solutions that transform industries. TRIZ isn't just a philosophy, it's a toolbox filled with practical methods. First, there are the 40 Inventive Principles. These are patterns of creative solutions discovered across thousands of patents. For example, segmentation, merging, or taking it to the next dimension. Next, the Contradiction Matrix, a guidebook that matches your specific technical conflict to the principles most likely to solve it. For complex challenges, TRIZ offers ARIZ, the algorithm of inventive problem solving. This is a structured, step-by-step process to break down and analyze problems systematically. And finally, TRIZ maps out trends of technological evolution. These help us predict the natural direction of innovation, such as systems moving toward automation, increasing flexibility, or miniaturization. Together, these tools form a complete system that turns vague challenges into clear, solvable pathways. Thank you for watching. If you found this video useful, please like, share, and subscribe.